So, you just watched Loki mini-series. Loki has opened up the multiverse. He Who Remains' demise has caused the once isolated sacred timeline to fully branch off into different paths and, potentially, collide with other timelines. But what exactly are the intricacies of the multiverse? Multiverse theory suggests that our universe, with all its hundreds of billions of galaxies and almost countless stars, spanning tens of billions of light years, may not be the only one. Instead, there may be an entirely different universe, distantly separated from ours, and another, and another. It could be that our universe is just one member of a much grander, much larger multitude of universes, a multiverse. The concept of the multiverse arises in a few areas of physics and philosophy, but the most prominent example comes from something called inflation theory. Inflation theory describes a hypothetical event that occurred when our universe was very young, less than a second old. In an incredibly brief amount of time, the universe underwent a period of rapid expansion, inflating to become many orders of magnitude larger than its previous size, according to NASA. Inflation of our universe is thought to have ended about 14 billion years ago, said Healing Deng, a cosmologist at Arizona State University and an expert in multiverse theory. However, inflation does not end everywhere at the same time, Deng told Live Science in an email. It is possible that as inflation ends in some region, it continues in others. Thus, while inflation ended in our universe, there may have been other, much more distant regions where inflation continued, and continues even today. Individual universes can pinch off of larger inflating, expanding universes, creating an infinite sea of eternal inflation, filled with numerous individual universes. In this eternal inflation scenario, each universe would emerge with its own laws of physics, its own collection of particles, its own arrangement of forces, and its own values of fundamental constants. This might explain why our universe has the properties it does, particularly the properties that are hard to explain with fundamental physics, such as dark matter or the cosmological constant, Deng said. If there is a multiverse, then we would have random cosmological constants in different universes, and it is simply a coincidence that the one we have in our universe takes the value that we observed, he said. The biggest piece of evidence for the multiverse is that life exists, particularly intelligent life capable of making cosmological observations. Certain aspects of our universe seem special and important for supporting life, such as the longevity of stars, the abundance of carbon, the availability of light for photosynthesis, and the stability of complex nuclei, said McCullen Sandora, an affiliate research scientist at the Blue Marble Space Institute of Science. But all these features are typically not the case if you get handed a random universe, Sandora told Live Science in an email. The multiverse offers one explanation for why all these features are favorable in our universe, which is that other universes exist as well, but we observe this one because it's capable of supporting complex life, Sandora said. In other words, so many things had to line up just right in our universe that the existence of life seems improbable. And if there was only one universe, it likely shouldn't have life in it. But in a multiverse, there are enough chances for life to appear in at least one universe. But this theory is not especially compelling, so most scientists remain skeptical of the multiverse idea. Many scientists have tried to find more physical, hard evidence for the multiverse's existence. For example, if a neighboring universe happened to be close to ours long ago, it may have collided with our universe, creating a detectable imprint. That imprint could be in the form of distortions in the cosmic microwave background, the light left over from when the universe was 1,000,000 times smaller than it is today, or in strange galaxy properties in the direction of the collision, according to the Early Universe blog published by University College London. But all of these types of searches have come up empty, so the multiverse remains hypothetical. Deng is searching for evidence of the multiverse by looking for special kinds of black holes that could be artifacts of pieces of our universe that separated into their own universe via a process called quantum tunneling. If some regions of our universe separated this way, they would have left behind bubbles in our universe that would turn into these unique black holes, which may still exist today, according to Deng. Perhaps the most mind-bending implication of the multiverse is the existence of doppelgangers. If there really are an infinity of universes but a finite number of ways to arrange particles in any individual universe, then the same patterns are bound to be repeated, eventually. That would mean that at some incredible, but finite, distance, there would be an exact copy of you reading an exact copy of this article. And because there would be an infinite number of universes, there would be an infinite number of these exact scenarios all happening simultaneously, according to the Institute of Physics.